Hi, Mr. Cole here again, and today's topic is solving systems of equations by elimination. Our goal for today is we're going to solve systems of equations by eliminating, and then our California standards again is California 9.0. Alright, let's go ahead and get started. Alright, so this is again part of the whole goal of solving for systems of equations, which is we still have two linear equations here. They both create a line, and where that line meets, that little dot, that's what we're looking for. We're looking for that particular little intersection. And I know it looks like a lot of work just for that particular thing, but that's basically what we're doing here. Alright, so let's go ahead and start off with solving systems of equations by elimination, and in this case we're going to go ahead and use adding to help us out here. So first off, we're going to align the terms. Now notice the terms are already aligned. That was just easy. So right here, x's, y's, and then of course your constants or your numbers. And what we're going to do here is we're going to go ahead and look for a variable to eliminate. And how we eliminate this is if we were to take negative 4x and positive 4x, and if we were to add them together, well, that's one very, very special thing that I just did right here, which is I put parentheses around this entire thing, because we're adding that entire term, okay? That entire equation. So here, negative 4x plus 4x, that's actually gone when I add them together. I can add this together. So that's going to give me negative 2, positive 8, it's going to give me 6y. And then I'm going to add these guys together, which is going to give me negative 36. Now again, just a little background on this one. A lot of times it kind of depends on which way or which method that you want to figure the little intersection part out. And you can do this again by graphing, or what we did before, which was substituting. Sometimes eliminating just makes more sense because you don't have to solve for y, you don't have to make, or solve for x, you don't have to make a variable equal to something. So this one, when you have it here and it's nicely spelled out, where you have the negative 4x and positive 4x, you know they can go away, so all you're left with is just this. So a lot of times this might make better sense that it's a lot easier, okay? And again here, if you look at it, instead of going through all that substituting, which I could have done here, I'm just going to go ahead and just figure it out from here. So here I have y is equal to negative 6. Now again, we only have one part of this. We have just the y part of that ordered pair, so now we're going to substitute this into any one of our equations, and just to make it easier for us, I'm going to substitute this into the first one. So if I were to rewrite this out, it's going to be negative 4x minus 2 multiplied by negative 6 is equal to negative 12. And then I'm going to go ahead and continue on. So here I have negative 4x, and then negative 2 times negative 6 is going to be positive 12 is equal to negative 12. And then subtract 12 from both sides. I'm going to have negative 4x is equal to negative 24, and that's going to give me x, and I'll just continue on here. Negative 4x divided by negative 4, and very, very important to divide by negative 4, is equal to negative 24 divided by negative 4. I now have x is equal to 6, and so our ordered pair is 6 from here, the x, and negative 6. So we had a comma. Alright, so this again is elimination by adding, and again, and how the numbers look kind of determines if you're either adding or subtracting. In this case, because I want to get rid of, and they are complete opposites, I can just add them together to get rid of that completely, and that just leaves me with the y value. Alright. Okay, so let's try one by eliminating by subtracting, and again, same thing, we're going to align the terms, and in this case, if you look at it, the terms are already aligned. We're going to eliminate, then we're going to substitute, solve it, and then again, get our ordered pairs from our two values. So the first thing we're going to do here is we're going to go ahead and eliminate what we can. And if you notice, I have a plus 2y and a plus 2y here. I know that if I subtract them, then that's going to give me my answer and eliminate this completely. So what I'm going to do here is I'm going to go ahead and do this. And again, very important, you want to put the parentheses around that, because what that basically means now is you are actually taking this and you are distributing this to everything here. Okay, so just to let you know how it's going to look like, it's going to be negative 8x negative 2y, and then negative 30. Okay? So let's go ahead and come down on this one. So here, positive 2y minus 2y, that's gone because we're subtracting them. Now we have a 7x and a negative 8x, which gives me a negative 1x is equal to, and then 24 and a negative 30 is going to give me a negative 6. And if you look at it, how easy it is that you just came from these two things just to get x right here. If I divide both sides by negative 1, I now have our answer of what x is going to be, which is 6. Okay? Now I'm going to take this and I'm just going to plug it into any one of these that I have up here. I'm going to take the top one, makes it a lot easier because it's already a positive, so I'm going to take 7, multiply that by the 6, plus 2y is equal to 24. And if you notice, I'm trying to solve for y because I already have 6 right here. That's 42 plus 2y is equal to 24. Let's make that a better 4. So I'm going to subtract 42 here, subtract 42 here. I now have 2y is equal to, and that looks like 18. So it's going to be a negative 18. Let me see. Yep, negative 18. And then divide both sides by 2. Y is equal to negative 9. And then to rewrite, x is 6 and y is equal to negative 9. Alright, so this one was elimination by subtraction, and don't forget this part right here, and I'm going to go ahead and put a star right here. Very important that you change everything up, okay? You didn't have to do that for addition because when you add, everything just kind of stays the same. It's when you subtract, you are actually subtracting this term, subtracting this term, subtracting this term, okay? Alright, so now we have our final one, which is eliminate by multiplication. And what happens if you have nothing in common? Well, what you can do is you can create something in common. And I'm looking at 9 and 3 here, and I can make the 3 into a 9. It's already a subtraction, so all I really have to do here is, first of all, I'm going to align it. They're already aligned, x, y is in constant. And all I'm going to do here is I'm just going to multiply this entire term by 3. And I can do that equally because if I multiply this side by 3 and this side by 3, it still keeps things equal. They're still equal to each other. So I'm going to rewrite this. It's going to look like 3x minus 9y, which is what we wanted, is equal to negative 18. And don't forget, you are distributing to all of them. Okay? So that's our new equation for this one. And I'm going to do some quick cross-cutting on this one. And again, I'm going to add here, okay? I'm adding because I can get rid of my y's right here. So here, I have negative 4x plus 3x, and that's going to give me a negative 1x. And then on this side, I have 9 and negative 18, which will give me a negative 9. Divide both sides by negative 1, x is equal to 9. So already we've gotten our x. And all we have to do now is just plug this into any one of our equations. I'm going to go ahead and put this one into, let's put it back on the top. Actually, we can put it back on this one. Let's put it back on this one, and then we can solve for y, and that makes it a lot easier. So we're going to put it back into that one, or we can put it back to this. Any one, it really doesn't matter. So let's go to put it back into the original one. So if I do that, that's going to give me 9 minus 3y is equal to negative 6. I'm going to subtract 9 from both sides. I now have negative 3y is equal to negative 15. Divide both sides by negative 3. And I have y is equal to 5. I now have our 2 points, which is going to be 9 and 5. Alright, so once again, this is a multiplication problem first because we needed to manipulate one of the equations so that way I could eliminate. And once I'm done here, then I just solve it like what we did on the other two with adding and subtracting. And then we figured out our final step, which is to get our ordered pair. Okay? Alright. So if you'd like to see more videos, just go to www.youtube.com/user/TycoDad. And thank you very much.